Okay, so for this problem, we have the following. Consider the following unbalanced equation. So we have Al4C3 plus H2O will yield us AlOH3 plus CH4. The question stem is asking how many moles of aluminum hydroxide will be produced when 0.600 moles of methane is formed. So first of all, we need to see how many atoms are present of each element in our unbalanced equation to find out what we need to do to balance it. So let's count up everything we have. So we have 4 atoms of aluminum, 3 atoms of carbon, 2 atoms of hydrogen, and 1 atom of oxygen for the reactant side. And on the product side, we have 1 aluminum, we have 3 oxygen, and 3 hydrogen. So this subscript here gets distributed to each element in the parentheses. So then that's why we get 3 oxygen and 3 hydrogen. So 3 oxygen, 3 hydrogen. There's also 4 hydrogen coming from this methane, so that's why I added 3 and 4 to get 7. And then there's 1 carbon atom. Okay, so that's what we're given. And so let's attempt to balance everything. So I would start with the most complex molecule that you have, which is the aluminum hydroxide. And I would just start with the goal of getting the aluminums balanced. So we put a 4 in front to help us get the 4 of aluminum to get these to match up. So when we did that, we got 4 aluminum, we got 12 oxygen, because it's like saying 3 times 4 is 12. And we also got 12 hydrogen as well, and the 4 that was still there from before. So we have now 16 hydrogens and 1 carbon. We're getting closer, but we just only have 1 element balanced. So let's choose carbon next to balance. So let's put a 3 in front of the carbon, and it looks like we're getting closer because we have 3 carbon on this side, and when we add the 3, we now have carbon on this side, and this also gave us 24 hydrogens now, because 3 times 4 is 12, and then from before we had 4 times 3 is 12. So 12 hydrogens from the aluminum hydroxide and 12 hydrogens from the methane. And so now we just need to balance the hydrogen and oxygen on the reactant side to match up to these. So what should we do? We should add a 12 to water. And so we now have Al4C3 plus 12H2O to give us 4AlOH3 plus 3CH4. So let's do a final check. We have 4 aluminum, 3 carbon, and 3 carbons. And we have 24 hydrogens and 12 oxygens. And on this side, for aluminum, 12 oxygens from distributing that 3. We had the 3 oxygens before and times that by 4. That will give us 12. And for the hydrogen, we have 3 here. So 3 times 4 is 12. And we also have 12 from the methane if we multiply 3 times 4. So then 12 plus 12 is 24 hydrogens and 3 carbons. And it looks like everything matches: 3 carbons, 24 hydrogens, 12 oxygens, and 4 aluminums. Okay, we're balanced. So given that, we can now determine the mole ratio that we need to answer our original problem, which was asking for how many moles of aluminum hydroxide do we yield if we start out with 0.600 moles of methane. So we have a 3 to 4 mole ratio, as we see here. We have 3 moles of methane for every 4 moles of aluminum hydroxide in our reaction. So we set it up to get our desired product in the numerator, and we just cancel the units to see that we have 0.600 times 4 divided by 3 will give us 0.800 moles of aluminum hydroxide. Forgot to write the units, but you should do that in or on your exam. Okay.